Welcome back. This time around, we're going to look at some matrix operations, but before we do that, we need to look at some key terminology. Okay, so the first bit of language we're going to introduce is this idea of an order of a matrix. And all an order of a matrix is defining the number of rows and columns it has for quick and easy analysis. Okay, so when we talk about order, we first have to specify the number of rows it has and then the number of columns and write that as m by n if we have m rows and n columns. Okay, so for example here in this first one in the lower left, we see that we have 3 rows, those go horizontally, and then we have 2 columns, so the order of this matrix would be a 3 by 2. Okay, this next one we have 1 column and 2 rows, so it would be a 2 row by 1 column matrix. Next one, we have 3 for each of the rows and columns, so this is a 3 by 3 matrix. And this last one, we would say we have 1 row by 3 columns. All right, so just some notes on that. Next, of these matrices that we just looked at, some of them are kind of special. Okay, and when we have a matrix that has only 1 row, then we say it's a row matrix. Okay, so there we have a row matrix. Similarly, if we have a matrix that has only 1 column, then we say it is a column matrix. Okay, and then when we have the number of rows and columns being the same, then we have a square matrix, and that makes sense because it looks like a square. Okay, the last type of matrix that we need to be really familiar with, and this happens to pop up all over, mainly in the next section 9.4, is this identity matrix. Okay, and we call this identity matrix, it's of order n. It's going to be a square matrix where the main diagonal is 1. So when we have a 2 by 2 matrix, it would look something like this, and then the off diagonal elements are 0. Okay, so 1's on the diagonal, 0's on the off diagonal. The identity matrix of order 3 by 3 would be 1, 1, 1 along the diagonal, and then 0's off the diagonal. Okay, and you can imagine this gets just larger and larger, and that's why you can have it of order n by n. Okay, lastly, okay, so far we have order, we have row and column matrices, square matrices, identity matrix. The last little bit is talking about now not a different type of matrix, but notation within a matrix. So we, at least in higher mathematics, we end up representing a matrix just as this A with the brackets Aij. Okay, that's just in general how we can represent it. And we let I be just the index that goes through the different rows and j be the index that goes through the different columns. Okay, but when we're asked for a specific entry, Aij, that means we have to look at the intersection of row I and column j. So, for example, here's a matrix A. When I ask for the entry 2, 2, that means the entry from this matrix that is in row 2 and column 2. Okay, so then using that matrix, I'm in row 2, column 2, intersect that, that's 1. Okay, next, A3, 1, that means row 3, column 1, okay, that's 3. And lastly, A1, 2, I'll let you pinpoint it here for a minute. Okay, it should be row 1, column 2, so minus 2. All right, so just be aware of that notation as well as all the different language here. We will be talking about order specifically in probably every single video here on out when we talk about matrices, that is. So very important concept that we get the order of the matrix down and then also be familiar with these other terms.